Alright guys, so today we're going to be doing an example problem that deals with the average normal stress and the average shear stress. Determine the largest load P that can be applied to the frame without causing either the average normal stress or the average shear stress at section AA to exceed 150 megapascals and 60 megapascals respectively. Member CB has a square cross-section of 25 millimeters on each side. So as we can see, the cut made by AA is a vertical line. So we have to figure out the area of AA. By using some trig, we can find theta right here is equal to tan inverse of 2 meters over 1.5 meters. Theta is equal to 53.13 degrees, and thus from this we can draw that we're going to be taking a closer look right here. So that triangle will look like this, with a 90 degrees right there in the corner. So from the Z pattern, we can find that this is theta, and that this we will call alpha. Alpha is equal to 90 degrees minus theta. Alpha is equal to 36.87 degrees. Using that, we can find AA now. AA is equal to this right here is AA, and this is 25 millimeters right here. By using trig, we can find that the area of AA is equal to 0.025 meters squared over sine alpha is equal to 1.0417 times 10 to the negative 3 meters squared. Now we have to take a free body, using the method of sections, we will take a cut of the member BD and we will analyze the forces within to determine the stress. So this cut right here is AA, and this right here is where P is applied. We will not use P, but we will rather use one resultant force, FBC, that is in line with the member BC. So at AA there is a normal force, a shear force, and a moment. So in order to find the normal, we will take the sum of all forces in the x, and n is equal to P over sine theta, which represents FBC, times cosine theta, which we can represent as P over tan theta. And next we will find the shear force using the sum of all forces in the y direction. So it's equal to the shear force minus FBC in the y direction. Sorry, we will just write that as FBC sine theta. Shear is equal to P over sine theta times sine theta, which cancels out and just leaves us with V equal to P. Now we will write, using the information we were given, our inequalities. The maximum normal stress is less than or equal to the maximum normal stress must not exceed 150 megapascals. So we write it as less than or equal to we find that P must not be greater than 208 kilonewtons. But since we were also given the shear stress, we must calculate that in the same manner. Therefore, the maximum load P is equal to 62.5 kilonewtons.